code in there which makes it a fuzzer. And one of the things that's really cool about Scapy is that basically it's got support for 36 protocols or something. And what the fuzzing function does is it just takes the protocol and just goes randomly through all the arguments. Just if it's an integer, it'll just put some stuff in there, some random stuff in there, and it's an endless loop. And that kind of gives you potentially complete code coverage of the protocol. Obviously, that's not going to always work because you want to have some things in it. Like if you have a protocol that says, I'm only going to parse version 4 of this protocol, you want to override that particular element in the protocol and say it's version 4. And you can do that with Scapy. Basically, with Scapy, every layer of your network is an object. And your object, you can basically say this element is going to be something that I want it to be, and then just say fuzz, and it'll just fuzz it. And you can, when I was at Bucksec with Philip, he had just implemented the fuzzing stuff, and I was like, why don't you try it against the ISC NTPD, the network time daemon, because it's pretty bad code, and you should probably find stuff in there. So he ran it against, which is, actually I wanted to give a demonstration here, but I didn't prepare for that. He ran it against the ISC NTPD, and not surprisingly, within a couple of seconds, we got a seg fault. Yeah, I really wanted to show you guys a demonstration, but yeah, well. We should check out Scapy. It is so much more than just a fuzzer. It does really neat stuff. And the other thing is that and I can actually show this. It's really easy to add new protocols. So Scapy doesn't have support for Sun RPC, but if you just do this, now Scapy has support for some basic Sun RPC stuff. So it's exceptionally easy to add protocols to Scapy. And the other thing is, if you're going to have stuff that generates, like checksums and stuff like that, you can easily say this field will need this function to generate CRC2 or some other kind of checksum stuff. So enough about Scapy. I'm kind of in love with Scapy, I guess. It's a really neat tool. Also, I mean, you can do anything with Scapy. Just while I was preparing for my talk, somebody came sitting next to me and he wanted to build a MAC address brute forcer because when you've got port security. And he's like, I don't want to write it in C because it's going to take me a couple of hours and so much code. And I'm like, do it in Scapy. And turns out you can do it in a one-liner. So yeah, this is where I'm kind of done with the first part. There are tons of more fuzzers. It's certainly not a complete list. These are some of the ones that I really like and some of the ones that are publicly known to find lots of cool stuff. But fuzzers they're basically the cool thing these days, and everybody's developing more and new fuzzers and cooler fuzzers. If you want to fuzz something, Google should be your first thing. Go to Google, say fuzzing, and then the protocol or the file type or the API you want to fuzz. And if you're a bit lucky, you'll find somebody who made a fuzzer for it. If not, you'll have to start from scratch. The other thing is that there are piles and piles of private fuzzers, and more specifically, there are piles and piles of commercial fuzzers. Things that cost 20,000 euros and stuff like that. So I can't afford those, but I've been told by some people that they're really cool. So the second part of my talk, yeah, kind of on schedule. So that's the first thing that should probably come up is, what kind of language, if you're going to write from scratch, what kind of language do you do? And these are just some pointers of things that I've come across. And so feel free to ignore them if you don't think it's true, but these are some of the things that, how I feel about writing fuzzers is that scripting languages usually are a lot better or easier because you can write less code and have the same thing that, you would have in C code. To give you an example and come back to Scapy, is that the Microsoft bug where they had a bug in IP option parsing, and it was a proof of concept code public for that was a piece of C code, which was about 150 lines of C code. And in Scapy, that's a single line of code. So, and Scapy is written in Python, by the way, so that's one line of Python code, basically. So scripting languages are really cool, and it goes a lot faster if you write stuff in scripting language, usually. The other thing is obviously that, because scripting languages are generally slow, is that your fuzzing on itself will be slower. And one of the things I've noticed about Python is that it's really slow compared to like Perl or something. But you can optimize Python code, so that's good. Most people also recommend using scripting languages because it's just easier to write stuff. However, one of the things that I've kind of experienced is that these kind of scripting languages, they're really cool if you want to do like ASCII-based protocols and stuff like that. But if you've got stuff where you've got a lot of binary data, it gets kind of messy. I mean, like in Perl and Python, you've got to use pack and things like that. In C, you don't need those things. It's all native in C, basically. So if you're going to do a lot of binary stuff, it's probably not a bad idea to use C. Right. Besides all of that, if you don't like any of the languages and you want to write something in Dylan or Lisp or Smalltalk or whatever, go ahead. You should choose a language that you're comfortable with. But these are just some of the things I've come across. Right. So the other thing is smart fuzzers, or not smart fuzzers. Basically, you've got two kinds of fuzzers. You've got dumb fuzzers and intelligent fuzzers. And the difference is that with a dumb fuzzer is that usually it takes you between a couple of minutes and an hour or so to write one. So there, you can sit down, almost get one immediately, and just start fuzzing. The thing is that with dumb fuzzers, you usually don't know the specifics of a protocol, or don't want to know the specifics of a protocol or a file layout or some API, and you just you look at what's valid and then just change some things in there and pass it on to whatever you want to try and fuzz. That's shockingly effective. Honestly, I mean, like the Mangle stuff, which does pretty much the same thing, really took me by surprise. I never imagined that you could break IE and PHP and pretty much a lot of other stuff with it, but it does work. The one thing is with dumb fuzzers is that if there's going to be compression and encryption and checksums, that you're not going to get far. Building intelligence fuzzer is basically the opposite. You know the protocol and the file layout, and you're going to implement the fuzzing. You're going to implement the encryption and compression and checksums and whatever you need. So building intelligence fuzzers takes a while. Obviously, they'll be able to fuzz a lot more and go a lot deeper in a lot of code paths. So intelligent fuzzers almost always give you better results than dumb fuzzers. So it's kind of a trade-off. I mean, if you just want to go out and find one cool bug, then dumb fuzzers usually will give you good results. If you want to try and get complete code coverage, you probably end up building an intelligent fuzzer and spending a couple of days or weeks or even months developing one. So intelligent fuzzers take a lot longer to write, but they give you an awful lot of things, usually. Right. So some of the things that are interesting to fuzz, binary files, movie stuff, and lots of programs that interpret them, QuickTime, Real Player, Media Player, M Player, tons of stuff. And those are interesting. Say for executable files, the Mako and ELF and whatnot. Because you can pass those to a kernel, and if they kind of make a crucial mistake there, like let's say they take some link and they cause a heap overflow, whatever, that's a local root and that's a local kernel bug. So those are kind of interesting. Some more like Office documents, like OpenOffice, graphic files, and another neat one is file systems. Because, for example, on Linux, you've got like tons and tons of file system support. You've got like, with the exception of ZFS, you've got like JFS and UFS, XFS, Ricer, and about 20 other file systems. And all of these, the kernel has to like parse all these file systems. And there's lots and lots of things in there. When I had used the Mangle tool over RicerFS, when I hit the enter button, I got a kernel panic. So lots of things that you can do there. Not binary files. You can, stuff like XML configuration files, those kind of things. You probably want to have smart fuzzers there, or at least take a known file that's known to be good, and then have something that's somewhat smart that can say, this looks like a string, so I'll change it into something smaller, or put %n or whatever in it. But usually you want to have some kind of intelligence when you're going to parse stuff that's not binary. Right. Yeah, more stuff to fuzz. You can fuzz, FTP protocol, obviously HTTP, DHCP, NTP, any protocol you can think of, you can probably fuzz. One of the interesting things about FTP is that you've got a lot of FTP fuzzers out there, but at least it looks to me that they're all exceptionally trivial. They take a list of the commands you can and give in the A and B, and then some, the more advanced FTP fuzzers, they try some globbing bugs and maybe directory traversals, and that's good if you want to find bugs in tutor FTPD or something on Windows, which nobody uses. But if you want to, try and be serious about it and see if you can find some neat stuff in like Pro FTPD or something, you're going to have to look at stuff like race conditions, signal race conditions, because you can cause signals with that, like some timing issues. And nobody's ever looked at that with FTP fuzzing. It kind of amazes me, because my guess is that you're going to find a lot of cool stuff there. Right, so that's network protocols. APIs, system calls, are the obvious one. Graphic libraries are probably the also exceptionally obvious ones, because they're going to be parsing a lot of length fields and stuff like that. And you just got to get it wrong once, and bam, there's a heap overflow there or something. Right. So even more stuff to fuzz. SUID files, which is what I talked about in like the third slide or something. Where you can do like arguments, obviously, environment variables, signals, standard input, and for example, also open a lot of file descriptors, and then open 50,000 files, and then don't close them and call a suite file. And for example, if you do that in Solaris, you open 50,000 files, and you run the ping, you get a seg fault. And if there are any OpenBSD developers in the room, they'll probably go like, yeah, we know those kind of bugs. I hear some people laughing, so some people know what kind of bugs I'm talking about. But basically what happens when opening a lot of files is if you've got select loops and stuff like that, you've got something which is called an FD set array, which is a static array on the stack usually. And it usually can only hold like 1,000 or 2,000 files. Basically it's got 1 bit for every file set. So that means if it's got support for 1,024 files, and you've got 1,025 files open, it'll write 1 bit beyond that array. So those kind of bugs are pretty neat. And like on the BSDs, they fixed most of those. On Linux, they're pretty much not exploitable because of very strict R limits. But stuff like HP Unix and Solaris and a lot of other things, just if you open a lot of file scripts and run suites, 9 chances out of 10 you'll get some very interesting bugs there. So and you can fuzz those things. I've never seen anybody do it, but that would be really interesting. And pretty much any input suite can take, and it's a lot of stuff, a lot of input. Right. So if you're going to write fuzzing tools, there'll be some things that you want to look at. Okay. Obviously, size fields. You want to look at strings, and then like things that terminate some kind of data, and things that mark its beginning. Right, so let's look at size fields. Obviously, one of the interesting ones is negative values. I'm sure you've all heard of it or seen some of those things, but they do cause a lot of problems. If you give him -1 in some stuff, that might cause problems. Some more examples. Stuff around like the boundaries, like where you get integer overflows. Those are usually interesting, like 7FFF and then 08000, so some stuff like that. They can cause under-indexing, for example, negative values. They can also cause, if you just do a bound check and you store that stuff in a sign integer, and you check if it's bigger than some array, and then use that value to put in a copy loop, it'll get caused to do an unsigned integer, and very, very bad things happen. The other thing that is sometimes interesting is like if you've got binary protocols where you've got length field saying the string that's coming is 10 bytes long, and then you've got a string there which is not 10